Let's find the volume generated by rotating the region bounded by y equals e to the minus x, y equals 0, x equals negative 1, and x equals 0 about the line x equals 3. I think one of the hardest parts about this problem is the fact that we're revolving around something that is not an x-axis or a y-axis. It's a line. In fact, we're revolving this region that's shaded about the line x equals 3. So let's take a closer look at what's really going on here. I've already pre-graphed this region on Desmos, but let me emphasize really all the curves. This first curve on top of the region is the curve y equals e to the negative x. The curve to the right is x equals 0. The curve on the left side of the region is the line x equals negative 1, and the curve underneath is the line y equals 0. So first of all, knowing the bounds on the region is important. And what we're doing is we're taking this region and we're revolving it around the line x equals 3, which is a vertical line. So it's acting like a y-axis, and when we take this shape and revolve it around, can you kind of picture what's happening? It goes over here on this side, it connects into a circle, and so what's happening is we're getting this big cylindrical shape. But inside this cylindrical shape, right, we've got this kind of like, I don't know, some kind of a funky bowl, cylinder, funnel kind of thing going on here. And so that's what's going on. This is the shape that we're getting as we rotate around. So we have a really interesting thing that we're a three-dimensional solid that we're getting the volume for. All right, well, in this particular section, we are looking at using cylindrical shells to find that volume. So let me just jot down that note that we are using cylindrical shells. And the way to get a volume using cylindrical shells is we take our region and we, instead of cutting it into discs or washers, we are going to cut this region into a whole bunch of cylinders that we're going to add up. The cylinders are going to be centered on this axis of rotation, and they're going to be cutting parallel. We cut parallel to our axis of rotation to create this cylinder, right? So we're getting this huge big blue cylinder that rotates around. And I think I'm going to erase that red part here on this side so I can focus in on my blue cylinder. But this is the cylinder that rotates around our axis of rotation, or the line x equals 3. Now, our job is to go ahead and figure out what is the volume of a single cylinder and then add up all the cylinders across our region, and that gives us our total volume. So let's focus in on this single particular cylinder right here. First thing we're going to do is we're going to thicken that cylinder up a little bit. So we're going to give it just a slight thickness here in our cut, right? And that's going to make our cylinder just a little thick here. Specifically, since our cut is running along the x-axis, we're going to call that thickness dx. And the volume for a particular cylindrical shell is going to be dx times the surface area, which we have already talked about and discussed is 2 pi rh, where r is the radius of this circle and h is the height of the cylinder. So r is the radius of the cylinder or the circle that's across the top of our cylinder, and then h is the height. Well, the height is really easy to see. The height is simply the part that's defined by the upper curve, y equals e to the minus x, and the lower curve, y equals 0. So the distance between e to the minus x and 0 is just e to the minus x. So the height of our shell, no matter where we pick it along that region, is e to the minus x. That's our height. All right, so what about the radius? Well, the radius is actually a little trickier. The radius, as we said, is the distance from the axis of rotation all the way to the edge of where I'm cutting my cylinder. I can see in my picture that the distance from the axis of rotation to the y-axis is 3 units because I'm revolving around the line x equals 3. But to get a little farther to where this cut is happening, I have to add a little bit. What do I have to add? I have to add the absolute value of this distance. So let's say, for instance, I'm cutting it at x equals -1/2, right? It kind of looks like I'm cutting it almost at x equals -1/2. That means my total radius is going to be 3 units on one side plus an extra half on the other. Or in other words, 3 minus -1/2. If I follow that logic through, to get the radius of any cut along this red area, I need to take 3, my axis of rotation, minus that negative x value. So 3, excuse me, 3 minus x is a way to describe the radius of all of our cylinders that are going to be cut in this red region, which lie to the left of the y-axis. So now that I have all the pieces fit together to get the volume of a single cylindrical shell, I want to add them up or sum them up to get the total volume of this solid of revolution. So here we go. The total volume is obtained by summing up or adding up or integrating all of these cylindrical shells, which are defined to be 2 pi r, where r is 3 minus x, which is the radius of each cylinder, times the height, which is e to the minus x, times the thickness of each cylinder, dx. I'm going to be cutting along the x-axis, right? All of my thicknesses are running on the x-axis, and therefore my limits of integration also have to be on the x-axis, and those are the 2 lines that bound our region along the x-axis, which is going to be x equals -1 to 0. This integral right here will give us the volume for this solid of revolution. So let's go ahead and let's integrate this on a fresh new page. That is, we're going to take the integral from -1 to 0 of 2 pi times 3 minus x e to the minus x. And what do you want to do to integrate this? Now, there's lots of different ways to proceed. Some people just look at it right away and know what to do. Some people say, Tina, maybe I want to multiply this out. I know I have a product involved here, right? I can see I have 2 functions. Can't really do a u substitution. So what do we do when we have an integral with a product like this with an e to the x and then an algebraic function on there? Can you think of one of the tools that we've used? I'm just going to kind of jot down. What about integration by parts? Do you think that'll work here? When you have a product and you can't use u substitution and you've got a transcendental function with an algebraic function, often integration by parts is the key. And that's a technique that will work, an integration technique that'll help us solve this integral. So what are we going to do? Integration by parts means we're going to find a u value. We're going to find a dv or assign a dv. Then we're going to take a derivative with u. We're going to take an antiderivative with respect to v. And we're going to keep going. So let's see. So let's go to u and let's assign u to be 3 minus x, the algebraic function. And dv then becomes our exponential function, e to the minus x dx. Our next step is to then take the derivative of u, du, and that's actually going to be the derivative of 3 minus x with respect to x, which is just -1 dx. dv is going to turn into v by integrating both the left and the right side of this equation, this mini equation. So the antiderivative of dv is v, and the antiderivative of e to the minus x dx is just minus e to the minus x. And so this is our main setup for integration by parts, right? And our next step now is to use the formula. The integral of v du equals uv, excuse me, I said it all wrong. The integral of u dv is uv minus the integral of v du. So we want to convert into uv minus the integral of v du. And so let's rewrite our integral. I'm going to pull out 2 pi, and we are left over with uv, u being 3 minus x, v being minus e to the minus x, so that's u, that's v, minus the integral of v du, so that's e to the minus x with a negative, and du is minus dx. Our limits are -1 to 0, so I'm just going to tack them on at the back end to keep it kind of simpler that way. Alrighty, well, let's clean up what we've got going in here. So first things first, we have the negative e to the negative x. So if I take a negative e to the negative x and multiply it by 3 minus x, I think I get the following. So the volume is 2 pi times the quantity, negative 3 e to the negative x plus x e to the negative x. And that's because the minus together gives us that plus value. And over here, let's take care of these negatives over here. I've got a negative and a negative, which together combine into a positive. So I'm simply going to, over here, take minus the integral of just e to the minus x dx. One step at a time. Alrighty. Now, you might be done. Again, I'm just going to go very slow because I always make small algebraic mistakes if I don't go slow. Antiderivative of e to the minus x is just negative e to the negative x with a negative in front. So I think this is going to give me plus e to the minus x, and all of that is being evaluated from -1 to 0. And if I want to be a little trickier, I can notice that I have a negative 3 e to the minus x and a plus 1 e to the minus x. And so I could put together those and get negative 2 e to the negative x plus x e to the negative x from -1 to 0. Now, there's more things to do if I wanted to simplify a little farther by factoring out an e to the negative x, but instead, I think it's time for me to go ahead and just plug my limits in for x. So, what does that give us? 2 pi times the quantity, plugging 0 in first, negative 2 e to the 0 plus 0. Minus, and now we're going to plug in a -1. Negative 2 e to the -1, which is plus 1, plus -1 e to the -1, which is plus 1. Cleaning this all up, what do we get? 2 pi times the quantity. Negative 2 e to the 0 is just -2, plus 0 is just -2. And over on the other side, I have -2e minus 1e is going to give me -3e. And doing one more cleanup, let's see. So to me, it looks like I've got -4 pi plus 6 pi e. This, cubic units, represents the volume of that solid of revolution using cylindrical shells. Phew, that was a doozy. That one took a long time. I hope this makes sense. If you have any questions at all, please don't hesitate to reach out.